Hello everyone. Today I will introduce Python web crawler and anti-crawler mechanism. Since there is a lot of content about crawler and anti-crawler mechanisms, I will divide it into two courses to elaborate on them. In the first course, we will introduce the foundation of web crawler and the basis of HTML parsing. This is the basis of web crawler and anti-crawler technology. So we will focus on those basic contents. This course mainly contains two major portions. One is the basis of web crawler and another is the basis of HTML parsing. The basic of the web crawler includes the overview, the structure, and the use of URL-lib and HTTP-lib libraries. Now I will introduce a corresponding library called requests. The use of Python library. The second part is the foundation of HTML parsing. First, we will introduce Firebug as a corresponding tool. In addition, we will focus on regular expressions and introduce beautiful soup components. And finally, the storage of the whole data. Next, we will expand the corresponding content in turn. First, we will introduce the basics of the web crawler. What is the web crawler? The web crawler is known as a web spider, also called a web robot, which is pretty well known. It simulates the browser to send the network request, receive the response, and automatically grab the information from the web page according to certain rules. Such a program, we call it the web crawler or web spider. It will follow the hyperlink path of the network and collect data according to the preset rule. A web crawler has some other common names such as WebAnt, automatic search, emulator, or worm. All are the same concept. Crawler simulates the behavior of a browser. The more like the behavior of a browser, the better, the less easy it to be found. In fact, it is to simulate the behavior of a web browser, which is equivalent to a person using the browser to access the corresponding web content. What are the uses of web crawlers? Let's take a look. For example, the search engines, Baidu, Google, when they collect web content, they need to collect by crawlers. The second is the shopping assistant, which also needs to collect the corresponding data so that it can understand which products should be displayed to users. The third is data analysis. For example, in social networks, when we want to analyze the data of these social networks, we have to collect these data one by one by using web crawlers at first and then analyze them. Next is automatic operation, such as ticket grabbing and automatic attention, comment, and reply. For these mechanisms, it also needs crawler operation. It needs to get the content on the page so that it can respond to it. These are all scenarios of web crawler applications. What is the structure of a web crawler? The framework of a web crawler, it is mainly divided into three parts. The first is the controller. It is responsible for assigning word content and tasks to various crawlers with multi-threading. Each crawler has a single crawler thread, and the controller is responsible for assigning these tasks to each crawler's worker thread. The second is called a parser. After downloading the pages, the parser will perform page processing, mainly to get rid of JavaScript script tags, CSS code, space characters, HTML tags, then parse out of the contents we want, such as products, news, comments, and so on. After the content parsing, it becomes a standardized format. This process is called parsing, which is completed by the parser. The third is the resource library. The resource library is a place to store the downloaded web resources, which are usually stored in large databases like Oracle and indexing them. There are many data contents, and it is easier to use a large database, and it can store a lot of data. The workflow of the web crawler is like this. First, the crawler automatically obtains the URLs of the pages to be traversed. Next, by analyzing the information about the web links contained in the traversed pages. And this process can be repeated automatically. It starts with a set of URL links to visited, which can be called seeds. The crawler visits these links and identifies all the hyperlinks in these pages and then adds them to the list of URLs, which can be called the retrieval frontier, which can be used as a retrieval content and repeated according to these URLs. We can see that the crawler mechanism simulates the browser to send the corresponding request information and then parse it. It is an iterative process. There may be a lot of content. You need to control how to get the address of these link information, how to control the access order, and its access method. This is what you need to control in the future. Let's talk about a URL. The name of URL is called Universal Resource Locator. Its basic format is like this. First of all, the front is the protocol, for example, HTTP, HTTPS, or FTP. There are many corresponding protocols. Then it is the host name, server's IP address or domain name, and host is the IP address. Next is the port, which is optional. If it is HTTP, the default port is 80, while HTTPS port is 443. The port number can be omitted by default. For example, for HTTP, add the domain name directly, and its default is port 80. If port number is not 80, you need to add the port number description. Next is the path, which may be very long. It represents the path to access resources. It may have multiple directories, such as /res/document, etc. Next, the last is called the query string. It starts with a question mark and is the parameter of the request. There can be many query strings, each of which is connected by the AND symbol. We can add a number of query strings. In the end, there may be a number sign symbol. We call it an anchor. When the browser handles the anchor, it can jump to the anchor location of the web page. The URL we often see is the identification method used to determine an address of a complete resource on the internet. An address is a complete URL, can locate where it is. We often see the HTTP addresses. For example, http://localhost:8888/hello. Let's parse it. We can see the protocol is HTTP. The localhost is the IP address or called the host name. The port number is 8888. Its path is /hello, and there is no query string followed, which can be omitted. Let's look at how HTTP works. HTTP requests have two major methods. One is called GET, and another is called POST. The request, first of all, the data it sends, and its work are all carried out along such a loop. Send a request, then get a response, and send a request again and get a response again, and cycle this process. When sending a request, it will send out data. We call it a message. The first method is the request. We can use POST or GET, two approaches. What follows is the address requested by URL. Here, the host and port of the URL can be omitted because the server is already accessed, followed by the version of the HTTP protocol. The next content is the corresponding header. In the middle of the beginning of the header and the message, there are two blank lines, i.e. two enter characters. The text before the blank lines is the message header, while the text after the blank line is the message body. The header contains a lot of information, such as the source, content, browser type, and so on. The content of a message is the data to be sent. We can find that it is using the formal format, which includes name, password, and real name. which are all separated by the and symbol. This is the browser, which is the information sent by the client. The server will respond to the content according to what it receives from the message. The response of HTTP messages all consists of 4 parts. The first one is the status line. We can see http:/1.1 to 100 OK. This is the status line. It contains the response protocol and its version. 200 is its status code. OK is its message. Next is the message header. It will be a blank line. This blank line will be there for sure. All the following contents are the body of the response, which can be automatically parsed out so the browser can display the corresponding content. It is based on the HTTP protocol. We can see that every time the browser sends a request and the server returns a response. That is the communication mechanism between them. So the browser's behavior can be simulated by a crawler. The crawler only needs to simulate the process of sending the request, receiving and parsing the request. Then the crawler can simulate a browser. Let's have a look. There's a package called urllib in Python, which can easily parse the URL for processing. It contains 4 modules. The first is the request module, called urllib.request. What does it do? It can open and browse the URL. Send a request, which is equivalent to the process of sending a request. So it is equivalent to simulating entering an address in the browser and visiting the page. We can see the request method. For example, we open an address baidu.com. The obtained content is response.read. We can read it out, decode it in UTF-8 mode, and we will see the corresponding content. The second module is the exception handling module, which is error. During the whole process of using, we may have kinds of errors, which may be URL errors or HTTP errors. For example, problems occur on the server side, such as no response, wrong URL address, and so on. We can quickly catch the error on the server side and solve it. The third module is the parsing module. The parsing module is that when we receive the results, we need to process our content. This is to use the parsing template for processing, such as URL extraction, merging, link conversion, relative address, and so on. We can see that if we have such a code, we can organize it into our corresponding data, and we can send it to the server. The request is used here, and we can handle its errors in various ways. If the URL is wrong, we can capture it. For example, timeout. The server access timeout. We can get this error as well. In this way, we can get a robust, complete program. Using urllib, we can easily simulate the browser. At this time, we can visit different addresses and parse the corresponding content. In addition, let's take a look at urllib. There are some other functions. There are 2 very important functions. One is the web request. Another is the response receiving. The third function is setting proxy and cookie. In fact, a cookie is the data stored locally by some websites in order to identify the user's identity and track the session, which exists as a file temporarily or permanently saved by the client's computer. It is also saved in the form of a cookie file. The difference between its cookie and a session is that the cookie is stored in the client for authentication, while the session is the data stored in the server to record the user's identity information. These two are stored on different ends. The next function is exception handling. The last function is URL parsing. Here, we often need to add some header information. For example, when we're crawling the web, we will encounter some anti-crawler settings. For example, when the server knows the request is from a crawler, it would respond with a 403 error. In this case, the crawler needs to disguise itself as a browser to access it. So we need to add some headers such as cookies or other various contents. For example, the server is set to allow only local page links with refer check. If we just send the URL request, the server may be able to determine which is not from this site. At this time, we can add the information in the header. For example, adding user agent option, this probably can solve the anti-crawler mechanisms. Let's expand it in more detail. Start with the request method of URL-lib. The first request method is URL open, which is mainly used to simulate a web request and return an object of HTTP response. It's equivalent to entering an address in the browser and pressing enter to send it to the server. We need to specify the URL. May also need to specify its data or timeout time. Many other parameters as well. Another request method is url.request.request. This function is mainly used to construct a URL and return an object of url-lib.request.request. Let's take a look at the second method, URL error. Error is actually the exception handling. The exception handling module inherits from the OS error class and is the base class for the error exception module. All exceptions generated by the request module can be captured by URL error. It has only one attribute, reason, which returns the reason for the error. Then we can understand what caused the error. Let's look at URL error. HTTP error is the subclass of URL error, which is dedicated to handling HTTP errors, such as authentication request failures and so on. It contains several attributes. One is the code, which is the status code of the HTTP response, such as 404, 503, and so on. Another is the reason, which will return the reason for the error. The reason is an explanatory description text. Headers can return the HTTP response header, i.e., how the server returns information. Through this information, we can easily capture its errors and solve the problem in time. Next, we will talk about the URL parse module, which is a very important module. Parsing module, which actually contains two kinds of functions. First, what can URL parse? It is URL parsing, can be divided into URL string recognition and segmentation. For example, we need to divide the URL into two parts. Find its hostname and port, or extract its address and path. At this time, if we handle it manually, it will be more complex. Using this module, we can quickly parse it and get 6 strings. The protocol, domain name, path, parameters, query, and anchor points. It returns a name tuple of these 6 fields. We can see the corresponding content. URL onParse is actually the reverse operation. It is the opposite operation to parse. It can combine strings into a complete URL through a list or tuple, which is just following the previous form. At this time, it is very convenient for us to use parse first. After parsing, we can adjust the address. For example, process and change the page, replace the parameters, and then use onParse to get a new address. This is a way we are often using. URL split directly splits the URL string and returns 5 fields. It will merge params into the path, which means it does not have 6 fields, only 5. The fields of the request parameter will be merged into the path, and the results of the 5 corresponding fields will be obtained. In addition, there is URL onSplit, which is the same as this. It is a string that combines URLs. It must be 5. Here, 5 fields are combined to form a URL. This is the corresponding reverse operation. Using these methods, we can easily parse the entire URL, such as changing its path, parameters, and so on. They are all very convenient. There is also a function called URL join. which can conveniently combine two URLs and will use the URL to supplement the missing part. For example, a URL has the protocol and domain name path, and another does not. They will be joined together. Those fields that are not in the base URL will be added, and those fields already in the base URL will be replaced by those in the other URL. For example, we can get the entry address of the home page, and we also need to get a relative page address. After combining, we can get the absolute address of the relative page, so that we can easily combine. Some special characters often appear in our URL, so we can use the quote to escape. This is a method dedicated to the % plus number. If we have Chinese characters or other signs, the coding will be processed automatically. Of course, some symbols will not be processed, such as underscores, dots, or other special symbols. This method is often used in our path or the whole URL if there are special characters. Another corresponding method, called unquote, it is reverse operation, which is to replace them with characters. Well, we need to use the URL address, such as the file name, and we need to save it as a file. We will usually see the encoded characters. For example, we want to change the %20 into a string instead of an escaped character. Then, we can use this method to parse. There is another one called URL encode. URL encode is the GET request, and its parameter part is the query. In the query part, or to parse the data part in the post, we also need to encode. We call it URL encoding, because in the whole process of data transmission, if there is no encoding, we don't know what kind of encoding standard the data is, and errors may occur during data transmission. In many cases, we require URL encoding for the whole parameter data. For example, when we want to send the Chinese characters China to the port, we can use $name equals China directly. But China can't directly use the two Chinese characters of China. Then we need to encode them. Encoding also needs to specify its method. The encoding language is UTF-8. After encoding, we will get a string of characters, which is also similar to the form of % plus number, which is called the escape character. In this way, the server can parse the data normally. Next, let's look at the HTTP package. HTTP lib package implements the client-side protocols of HTTP and HTTPS. It is generally not used directly. On top of it, there are higher-level wrapper modules. Of course, usually we will use a basic module of HTTP for access, because the higher the wrapper is, the less flexible it is. In some cases, it may not be very convenient. We can see such an example. First, we import HTTP lib and URL lib packages. We need to send the request. Let's first construct our data. Let's take a look. URL encode gets such data, which we need to send out. For example, we can see the number, type, and action of data. We construct a request. The request header describes the format of URL encode form. Its format is plain, which is standard text. Let's connect to the server bugs.python.org. We use the post method to send the request to the server. Send the data and use this header. After sending, we use getResponse to get and return the corresponding request, and then we output its result, reason and read. And read is the actual content. Then we execute this method, which is a complete request. Here we can freely combine data, header, and a connection. And finally, gets its response status code. For example, if it is normal, it should be 200. The reason is the cause of an error. If there is an error in its return, finally we can see the return result. Next, let's look at requests. Python's requests let HTTP serve humans. HTTP serves human beings. Secondly, there are several parts. That is, we have an open source address and API documents. as well as some request features. Finally, let's introduce the installation method. Open source documents can be found here. There are many corresponding documents and APIs. The Chinese version can be found at this address. The second is some characteristics of request. First, it is a connection that supports HTTP. It can also support its connection pooling, support to maintain sessions using cookies, and simulate the way cookies are commonly used by our browsers. It also supports a file upload and directly submits the file to the server. It supports automatically determining the encoding of response content, such as GBK or UTF-8, which can be parsed automatically and does not need further process. Support internationalized URL and automated encoding of posted data. It is very convenient for us to use the whole HTTP. The installation is also very simple. We only need to use pip install requests to install it, or use easy_install requests. These entire packages also contain all the main core modules that we need to use in the crawler. Next, I will talk about another big part, which is HTML parsing in HTTP. This is the parsing of the response part, which we actually call HTML parsing. What we see on the web page is a browser is the result of the presentation. That is, the expression after the HTML code is finally organized. But before we do that, we need to understand how the results returned by HTTP are parsed and constructed. Let's start with Firebug. Firebug is an extension tool developed in the browser Firefox. It inherited HTML view, edit, JavaScript control, network state monitoring, and so on. All the functions are included together. It is a very useful assistant for developing JavaScript, CSS, HTML, and AJAX debugging. Firebug is like a Swiss Army knife. It can see all the details of the whole page. This tool brings great convenience to web developers. It is a plugin and is open source, installed in the browser. It has been combined with the Firefox browser, and it is very convenient to use. When we need to view some information on the page in the browser, we just need to use Firebug to view it easily. Let's take a look at the interface of Firebug. After it is installed, we can open a web page of the test we need to use with Firefox. Now we can click the green button in the lower right corner, or we can directly press the F12 shortcut key to call up the Firebug plugin. We can see that Firebug is a plugin at the bottom, and we can see the internal data. And this time, the page will be divided into two parts. The top is our web page. Here is what we can see. Here is its control block. You can see the control pages, HTML code, CSS code, scripts, and so on. Here we can easily view the corresponding information. Let's take a look at the main functions of Firebug. The first is the console. The console function can easily display all kinds of error information on the web page. It can also print the log. We can also directly enter some of our commands here. That is, JavaScript debugging commands. To view the corresponding data as well as the variables on the web page, we can interact directly here, which is very convenient. The second is the function of HTML. The main function of HTML is to view the source code of the current page and edit it. For example, we can edit and display the logo and content of a style corresponding to a certain area in real time. In fact, the function of CSS is very convenient. We can see the CSS of the whole page definition as well as its CSS definitions and properties. At the same time, we can also make changes, such as changing the color position and so on. In addition, our script function is JavaScript. There will be many scripts on our page. We can view the script program and the corresponding methods. We can add breakpoints to the script program, debug the script program, or pause in the middle to track the problems and errors of the script program. In addition, the DOM function is the DOM of the web page, which is the interface structure viewer of our whole web page. You can see what the DOM architecture of our whole web page is like. Finally, there is our network function. The network function is that we can view every request and the return result of the whole browser communication. It is very convenient to see how the browser communicates with the server, including every request and return of network communication in the whole access process. Because sometimes you may not view the change of the data page, but it actually has a lot of network requests in it. At this time, we can use this to view. For example, some requests are requested through JavaScript scripts. Sometimes we may not know it, and we may not need to know its trigger mechanism. We only need to view the requested and returned content through the function of Network Viewer. There is also the CSS function of Firebug. CSS function can click the menu of CSS. You can see the definition of CSS of the whole page. You can also modify the method properties of CSS definition. We can also modify the style of a CSS. You can easily adjust, for example, do some style processing and so on. Script function factually is a very powerful script debugger. We can see all the JavaScript scripts defined on the page, which can be set by adding breakpoints or by single-step debugging, variable viewing, etc. We can also view the corresponding running time and statistical results. This can be very convenient to debug the script program. The DOM function is used to view the DOM information of the page, and the node can be located by searching. Network function is the corresponding network running time, as well as all its network request information. Let's take a look at a use case of Firebug. We can automatically enter Selenium on Baidu's homepage to search. In addition, we need to install Firebug and Firefinder plugins in advance. Here we insert a demo of Firebug. Then we can see that when we turn on Firebug in Firefox, open Baidu's homepage, we can click Baidu's textbook. Right-click to select the search element. We can get Baidu text box ID of the element we want to check. And also we can see the information of that element. We can see the input, its ID is key W. Next step, we click the Baidu button, right-click and select the Firebug to view the element. We can see that the ID corresponding to this button is Su. At this time, we can open our Firebug. Then we can choose Monitor under Script tab. In the new Monitor Script text field, enter such command, document.getElementBYID kw.value equals Selenium. Let's enter this button to call the usage method. First, the previous sentence means that we input Selenium into the kw object. Input the value into the box, and then click the Su button, which is equivalent to using code to simulate a manual operation. Next, let's introduce regular expressions. Regular expressions are a very powerful function. Due to text filtering and rule matching, we often need to find some specific content on the page. There are a lot of downloaded data. How can we filter it? In fact, there is a very important tool called regular expression, which is an indispensable and very important tool for the crawler. First of all, there may be a lot of content in the data, including web pages, code, and many other contents. Then we need a good way to find the text information we want. This tool is the regular expression. It is a concept in computer science often abbreviated as regex, regexp, or RE. What is a regular expression? In fact, in the beginning, regular expressions were used to search our gene sequences, and then they were extended to all fields where we need to search the text. The regular expression is actually a rule obtained by matching a series of strings with what we call a descriptor. Many editors use this method to find some specific text. This is the regular expression. Let's talk about it in detail. Give a regular expression and another string. We can achieve this goal. There are two purposes. One is called matching. Matching means to judge whether a given string conforms to the logic of our expression. The other is filtering. Filtering is to extract the part of the text string that we want through our regular expression. Let's take a look. This is our regular expression engine. We can get a regular expression object from the text of a regular expression. Next, we put in the text that the regular expression needs to process. Now we can get the matching result. Regular expression object is actually a result of compiling expression string through regular expression engine. Another one is called the matching result. Regular expression object matches the text, including the information of successful matching, string grouping, index location, and so on. This is one way a regular expression works. Next, we introduce the application of regular expressions. Let's start with character classes. The first one is called the dot, which represents any character. The bracket indicates that only a single character can appear. Note that one character in the brackets, ABC, indicates that A, B, or C can appear. It is equivalent to using A pipe B pipe C. It means that only A, B, or C can appear, any one of which is okay. The third is that caret characters appears in the brackets, which means that A, B, and C can appear. Any character which is not equal to A, B, or C is okay. And if there is A-Z in brackets, that means all the characters from A to Z. If you want to write A, B, C, D, E, F, G until Z, it's too long, then we can simply write A-Z. This is an English letter. This bracket means that any letter from A to Z can appear. Another one is A to Z and square brackets Hij in square brackets. This means that anyone from A to Z but not H, I, or J. This means all characters except H, I, J can be taken into account. The other is \S, which represents a white space character including space, tab, new line, form feed, and carriage return. \S means non-white space character. The non-white space character can be a letter, digit, or any special character. \d indicates a digit from 0 to 9. When we want to express numeric digits, we can use 0, 1, 2, 3, 4, 5, 6, 7, 8 in square brackets, or 0-9, or \d, which is more convenient. \D means not equal to 0 to 9. \w means a word character. Lowercase a to z, capital letters A to Z, underline, or digit form 0 to 9. All the common characters, i.e. the other words. \W means non-word character. This is the most widely used expression of the character set. Let's take a few examples. First of all, if we need to limit that only m to n digits can be entered, we can express it in this way. Use a brace to indicate how many times it can appear and how many times it can appear at most. M is the minimum number of times. If using 0, it may not appear. N can be equal to 5, which is 0 to 5. If there is no digit, it's okay. For example, if we want to enter a telephone number, the number is 2 to 5 digits. M is 2, N is 5. If you can only input digits or letters, you can use capital letters A to Z, lowercase letters A to Z, 0 to 9, plus an addition sign. Note that the caret sign in the front means the beginning of the whole string, and the dollar sign means the end of the string. If we want to verify the number of an ID card, the 18 ID number can be written in this way. First is the 17 digits, and the last one can be a digit or letter X. So we should write as this way. \lowercase d, capital letter X in double quotes, lowercase x. This means all three cases are okay. Combine them. It is the ID number of an ID card. The fourth example is that we can only use 26 letters, which is very simple. It's capital letters A to Z, lowercase letters A to Z, including digit. The fifth example is to check whether this special character is included, such as and % equals ? We can write it like this, putting these symbols in brackets, and the plus sign means that at least one of them should appear. Of course, it's okay to have more than one of them. and they will also be matched. Sixth, if you want to match Chinese characters, you can use this expression. In brackets, we use \lowercase u to indicate characters of Unicode. The characters in the interval from 4E00 to 9FA5 are all Chinese characters, which can appear at least 0 times at most any time. But more strictly speaking, 0 should be written as 1, and at least one character will appear. So the content has Chinese characters. If not, it is not Chinese character content. It is only empty character. The seventh is a regular expression that matches a URL address. It's preceded by the HTTP protocol. Of course, you can write this enumeration more rigorously as HTTP, HTTPS, or FTP. Then we can write arbitrary protocol with colon plus double slash, followed by the corresponding address. The last example is to verify whether the username and password are correct. For username, we can use this format to judge if it is correct. We can see whether the username satisfies the requirement of containing at least 5 and most 15 characters. It can also contain letters or digits such as 0 to 9. The first word must be alphabetic, 6 to 16 characters. This format can be used for checking the username and password. Let's introduce the advantages and tools of regular expression. What are the characteristics of regular expression? It is flexible, logical, and functional. It can be very fast to achieve complex control of strings in a very simple way. In addition, regular expressions are widely used in text content processing. We can see that the interface is the corresponding tool. Regular expressions can be used in many places, such as Word and Visual Studio. We can see that this is our common tool, in which we can write regular expressions or examples to check whether the whole matching or search results are correct. This helps us to quickly construct our regular expressions. Now, let's talk about the use of regular expressions. We can write the data extraction like this. Let's look at an example. First of all, this is the content which we will extract, a string. Assume we have a character like this. Capital letters, warning, colon, TensorFlow in lowercase. This is very common in the log output. Suppose we want to extract the date. The extracted date is October 11th, 2018, 15/28/19. At this point, we need to write a regular expression. This is our regular expression. And then compile it into our expression. To match, to find. First, \lowercase d represents a number, which consists of 4 digits. Then there are 2 digits for the month. Then another 2 digits indicate the date, and then a space followed. You can see that \lowercase s is a space. Then there are 2 digits, colon, 2 digits, colon, 2 digits. That's what we got here. This is the first part, this is the second part, and this is the third part. We can see that the result is the extracted date. Here I want to explain that when extracting this long string, if you write it as \d8 in curly brackets, is it okay? Yes, it is also okay. We can get this as well. But what's the difference? If we use \lowercase d, 4 in curly brackets, \d, 2 in curly brackets, \d, 2 in curly brackets. We can get the 3 parts respectively, which match the year, month, and date. If you use 8 digits directly, you can't tell what they are, and the following digits for time are the same. Next, we are going to extract email. How to extract email? We can see that this is a case of extracting mobile phone numbers. Here is a mobile phone number. We can write a regular expression that starts with 1, then 3, 5, 6, 7, 8. Of course, there may be mobile phone numbers starting with 17 or 18 and following 9 digits. Then we get a regular expression to extract a mobile phone number. After extracting find all, we can get this result. This is an example of extracting mobile phone numbers. Next, let me introduce the Beautiful Soup component, which is an HTML and XML parser, mainly to parse the content of the web page. What I introduced above is parsing through regular expressions. If we use soup, it can easily parse the whole content. It is a part of Python's built-in standard libraries. It can execute very fast and has highly fault tolerance. Besides HTML, XML data can also be parsed. It is easy to install, and it can be installed directly with pip install. This is an official document of it, as the link shows, which can be viewed for the corresponding usage and details. Beautiful Soup is to transform a complex HTML page into a tree structure. Each node of the tree is a Python object. After parsing, it is convenient to extract the content. There are 4 types of objects here. The first is called a tag, and the tag is the labels of HTML. It has 2 important properties, name and attrs. The second class is a navigable string, which is to get the text inside the tag with .string. The third is comment, a special type of navigable string, whose output does not include comment symbols. On the web page, we often see some comments. The last one is soup, which is an object that can represent the document. It turns the entire document into a very large special tag object. In this way, we can explain the entire HTML document or XML document layer by layer. Let's find out how to use it. First, we need to create a beautiful soup object and specify 2 parameters. The first is the HTML text string to be parsed. The second parameter tells it which parser to use to parse the HTML. This is our long string of HTML equals to such long parameters. After we get the content, we need to parse it with html.parser. This shows that is an HTML format. Next, after parsing, we can parse all label nodes through soup objects. At this time, if we need to select an element, we can use soup.head to get the head tag. Soup.head gets angle brackets head angle brackets title. We can also use soup.head.title to get the label of the title. That is its content. At this time, you can easily locate it. Next, get its properties. Soup.a gets all the A's links. The square brackets A tag, that is all the links. Through a.attrs, if we want to get its hyperlink, we will get the attribute of A's object. This attribute is written in it, such as CSS or href target, etc. These are all written in the tag, which is called its attribute. Then we can also use this method to get the content. For example, .string returns all the content of the current node, because .string does not know which one to get. The content of the current node will return null. If we use .text or .get_text round brackets, it will return all the content text content, of course including the content of its child nodes. Let's look at an example. Soup.title is such a result. If we want to get the content of it, which is a tag, we use soup.title.string to get such a result. We can also use soup.title.text to get the same result. But the difference is that if it has child nodes, .text can get all the subsequent content, which is very convenient. There is a corresponding search method called find_or. Using find_or to search, you can search the whole document tree. It uses the tag name to search for elements. We can also specify, for example, the attributes of the tag to filter and accurately locate a node. Find_or is the most common method to search. Its format is find_or name, attrs, recursive text, and other parameters can be added. The name is the tag you want to search. The attrs is its attribute. Recursive means if include its recursion, i.e. if search its child nodes together. The default value is true, which means to search it level by level. Text is to retrieve a string, such as what its text content is. This search will go by node, attribute, and a text. For example, find_or ul. ul means name, which means we want to search all ul tags. and find all Li tags in UL tags. We can see that there are two UL tags. One is here, another is there, only two Li. As we can see, it quickly navigates to two lists. Finally, let's talk about how we store our data. There are several types of data storage. The first one is very simple. We directly save it in plain text, such as JSON, XML, and so on. This method is very simple and convenient, but the disadvantage is that the subsequent retrieval is very complicated. Second, we can use non-relational databases, such as key-value database, MongoDB, Redis, and so on. The advantage of saving in this way is convenient because it only needs key value to save. But the disadvantage is that if we want to do some complex search, such as searching for multiple relationships, it will be quite difficult to filter. Third, we can use the binary file to save, which is commonly used in pictures, videos, audio, and so on. We can't save all these contents in the database, which is not convenient to search and view. At this time, we directly see it as our date file. For example, we can directly save a picture as a picture file. Finally, we often use a relational databases such as MySQL, SQL Server, and so on. It's very convenient to use a relational database to save data. In the future, if we want to search, index, or refuse the data, it is also very convenient. Here are a few examples. The first is to store the data in Excel. Storing data is the process of saving the obtained data to the local. We can save it as an Excel file. The module used is OpenPyXL. Use pip install OpenPyXL to install this module. After installation, we can use this template. The use process is divided into 4 steps. The first step is to open a new workbook. The second step is to find the active worksheet. When we use Excel, usually there are 3 worksheets. We can open the first one directly, and we need to activate the first one as well. Third, we can write it into information. We can write it into the cells by sheet, cell in square brackets equals content. Finally, we can call the save method so that we can save it to a file. Here's how it works. Write it to Excel. First, create a new workbook. As we can see, first we need to import the module, and then we use the object to create a new workbook. Next, we need to activate it. We can set its name as Sheet01. We write content, write test in shell A1. We can also write a different data in list equals row 1, row 2. Finally, we use .save method to save the file. Set the file name as test.xlsx. This is the complete saving process. That's all for this class. Thank you.